All right, if you've ever built an app, you know the feeling. The constant pressure to make it faster, smoother, better. And one of the most powerful tools in your arsenal is the database index. But how does it actually work? What's the magic behind it? Well, that's exactly what we're going to break down today.
It is the question that keeps developers up at night, right? You've launched your amazing new app, people are signing up, things are going great, but then the complaints start trickling in. It feels sluggish. Searches take forever. So what is really going on under the hood?
So let's set the scene with a really classic example. Imagine you've built a super popular social app. It's a hit, you've got hundreds of thousands, maybe millions of users. And a key feature, of course, is letting people search for other users.
But there is a huge problem. A single user search is taking a full 6 seconds. Now, in our world, 6 seconds is an absolute eternity. People are going to get frustrated, they're going to bounce, they're going to leave bad reviews. This is basically a 5-alarm fire for your application's user experience.
So what in the world is causing this 6-second nightmare? I mean, databases are supposed to be fast, right? Let's dig in and figure out why it's struggling so hard to find just one single person in that big sea of users.
The culprit has a name, and it's called a full table scan. Now, think about it like this. Imagine trying to find a word in a dictionary, but instead of using the alphabetical guide, you start on page 1, and you read every single word until you finally find the one you're looking for. It's thorough, sure, but it's painfully, ridiculously slow. And that's exactly what your database is doing to your data.
And the reason it's forced to do this is because of how the data is stored by default in something called a heap. And a heap is pretty much what it sounds like. It's just a big, unordered pile. When a new user signs up, their data gets tossed on the end of the pile. There's no sorting, no organization, it's just chaos. And that chaos is what forces the database into that slow, painful row-by-row search.
So, how do we fix this? How do we bring some order to this chaos and solve our 6-second query problem? Well, enter the hero of our story, the database index. This is the tool that was literally designed to solve this exact problem and give our app a massive, massive speed boost.
And I mean, just look at the difference. Without an index, you're looking at O of n over 2 efficiency. With an index, it becomes O of log n. But you know what? Forget the computer science theory for a second. Just look at the time. We go from a painful 6 seconds all the way down to less than 1 second. That is a complete game changer for your users.
Okay, so that is an absolutely incredible improvement. But it's not magic, right? There's a reason it works so well. So how does an index actually pull this off? Let's pull back the curtain and see what's happening behind the scenes.
The secret, the real trick, is that we're changing the entire data structure. We're going from that messy, unordered pile, that heap, to a highly organized, beautifully sorted structure called a B-tree. It's like going from a chaotic pile of papers on your desk to a perfectly organized filing cabinet.
The B-tree works almost exactly like the index at the back of a textbook. You don't read the whole book to find a topic, right? No way. You flip to the index, you find the topic, you get the page number, and you jump directly there. The database B-tree lets us do the exact same thing with our data.
So the whole process gets turned on its head. A search query comes in, but instead of touching the main table, the database first looks at the small, super-fast B-tree index. In milliseconds, it finds the right entry, grabs a tiny little pointer, which is just the address of the full record, and then it uses that pointer to jump directly to the correct row in the main table. No more full table scan, problem solved.
And that is such a key detail to remember. The index isn't magically part of your main table. It's a totally separate, much smaller table that lives alongside it, and it only contains 2 things: the data from the column you indexed, like the username, and those tiny little pointers. Because it's so much smaller and perfectly sorted, searching it is lightning fast.
Now, just like you wouldn't use a hammer for every single job in your toolbox, you don't use the same type of index for every situation. There are different kinds for different jobs. Let's take a look at a few of the most common ones.
So first, you've got your standard KEY index. This one allows duplicate values, so it's perfect for things like a user's city, where lots of people are going to have the same value. Then you have a unique index, and just like the name says, it does not allow duplicates. This is your go-to for things like usernames or email addresses. And finally, you have a full-text index, which is a specialized tool for doing complex searches inside big blocks of text, like a blog post or a product description.
And this brings up a really powerful side benefit. Indexes aren't just for speed, they're also for data integrity. When you add a unique index to a column, you're basically telling the database, hey,
You are the bouncer. Never ever allow a duplicate value in this column. It acts as a guard that keeps your data clean and reliable.
Okay, but here's where we get to the really critical part of the whole story. This incredible speed, this amazing power, well, it doesn't come for free. There is always a trade-off, and you absolutely need to understand the hidden cost of using an index.
That's right. There is no such thing as a free lunch, especially in databases. Every single index you add to your table comes with a cost. You are making a very deliberate choice to get that incredible read performance.
And there are two main costs to think about. First, disk space. I mean, the index is a whole separate data structure, so it physically takes up more room on your server. Second, and this is the big one, indexes actually slow down your write operations. Why? Well, every time you insert a new user into your main table, the database has to do extra work to also insert a new entry into the index B tree to keep everything in sync.
And that right there is the bottom line. It's the core concept you have to remember. Every index is a trade-off. You are consciously sacrificing a little bit of write speed and some disk space in order to gain a massive advantage in read speed. It is always a balancing act.
Which brings us to the final question. The one you should be asking yourself. You definitely don't want to just sprinkle indexes everywhere. That would slow your write operations to a crawl. You have to be strategic. So now that you understand the benefit and the cost, take a hard look at your own application. Which of your queries are the slowest? Which ones get run the most often? Which ones truly deserve the power and the price of an index?